Today, I need you to pick up 2 different notes packets from the counter over by the window by my desk. One is your new notes packet on 3D figures, and the second one that is next to it is on radical operations. So please go pick that up and then come back so that you can take some notes. All right, now go ahead and I want you to take a minute, pause the video, copy this. You should have done this for homework, so you can also, this is also a good check for you to see whether or not you got the correct formulas, and then we're going to come back and talk about them. All right, so with the first 2 columns, those you really just need to memorize, right? Things that I want you to think about: circumference is to a circle as perimeter is to a rectangle or any kind of figure, right? To find the perimeter, you're adding up the total distance that you would walk around that figure, all right? And then another thing I want to talk about for area of a parallelogram, the base has to be perpendicular to the height. So if we come down here, one common error is that, let's say this was 10, people would use this segment as the height. This is not the height, right? Because the height has to be perpendicular to the base. So if I draw in here, this would be the height, right? And then let's say that this piece here was 6, and then let's make this other piece 8, all right? So now, how would you go about finding the height? So go ahead and pause. Why don't you find the height, and then come back and you can check. So to find the height here, you need to use, hopefully you figured it out, the Pythagorean theorem, right? And so you would do 6 squared plus height squared equals 10 squared. And so then when you simplify that all out, you would have gotten 8 as the height, all right? So super important. That's the big common error that people have when finding the area of a parallelogram, all right, is using the Pythagorean theorem. All right. Now let's look at volume of prisms, volumes of cylinders, cones, pyramids, all right? So notice here, I'm not really using a specific formula for volume of a prism or volume of a cylinder, right? It's base area times height. So like if I'm looking at a prism, I could have this prism, which would be a triangular prism, which means then the base area would be 1/2 base times height of that triangle, and then times the height of the whole figure, right? And the height is the segment that joins the bases. That would be different than if I had a trapezoidal prism. So like this one here, I would have to use the formula for area of the trapezoid. So it might be helpful, like draw in the area of the trapezoid, right? And then you're going to multiply by the height. The height for this is the segment that is joining the bases of that trapezoid, right? Like this is the height, and this is one of the bases of the trapezoid, right? Okay, volume of a cylinder is exactly the same as volume of a prism. It's just that the bases of a cylinder are circles. So you're going to do pi r squared and then times the height. Okay, what I want you to recognize, right, is that volume of a cone and volume of a pyramid are basically the same thing as volume of a prism, volume of a cylinder. It's just that you're multiplying by 1/3, which is the same thing as dividing by 3, right? So for a cone, the base is always going to be a circle. So 1/3 pi r squared times h. Then for volume of a pyramid, it depends on what shape the base is. So if we look at just this pyramid, not the like rectangular prism that it's on top of, right? The shape of the base is a rectangle or a parallelogram, a rectangle. And so you would find the area of that rectangle and then multiply by the height of that pyramid, okay? I could also have a triangular pyramid, and then you would need to find the area of the base, which is a triangle, and then multiply that by the height of the whole pyramid, okay? So hopefully this is mostly review, all right? Another thing I want you to think of is look at these 2 figures here, okay? So those would be considered composite figures, just like when you put 2 words together and you have a compound word. These are compound shapes, right? Compound figures, because we're taking In the bottom one, a cylinder and a cone and putting them together. In the top one, we're taking a rectangular prism and putting it together with a pyramid. So for these, right, you would do volume of the cone plus volume of the cylinder. All right? And that's how you would go ahead and work through those. Okay? So now go ahead and we're going to, on the next page, you're going to copy the vocab, which is attached to a PDF in Classroom. So that's on page 3. And then go ahead and find page 6, okay? And we're going to kind of pick up where we left off with solids of revolution. So for example 1, okay, sketch and describe a solid of revolution. So when we rotate this, we're going to end up with a cylinder. So now the easiest way to draw this is to reflect the original figure across the axis of rotation, and then we're going to sketch in to make it more three-dimensional. And then I want you to find the volume of the cylinder. So volume of a cylinder, we said, was base area times height. And please keep your work organized like this. And so then we're going to do, okay, we've got pi r squared times the height. The radius here is 4. The height is the segment joining the bases, which is 9. And so then we'd multiply this out and we'd get 144 pi. And then our units would be to what power? Hopefully you said the third. Good. Because we're doing volume. So now go ahead and pause the video, work out B, and then come back and we'll go over it. All right, so you should have seen that this becomes a cone. And so again, if you reflect it, and then if you sketch in the base, that will give you your figure. So then we're going to do volume of a cone is the same thing as volume of a cylinder. It's just 1/3 times that base area times height. And so then it's 1/3 times pi r squared because the base is a circle. So like what I want you to avoid doing here is just plugging in the formula and not thinking about why you're using pi r squared, right? Like think about how these kind of pieces fit together. And then you can plug in the 1/3 pi 2 squared times the height, which is 5. Now, I want you to get in the habit when you know the answer is going to be a fraction is to put pi in the numerator. Oops. Assign pi to the numerator. Okay. And then we would end up with 20 pi over 3 units cubed. All right. So rather than writing 20 over 3 pi, please get out of the habit of doing that. Write it as just one fraction. And that will make life easier once we get to fourth quarter when we're going to get to graph things like this. I know. Try to contain your excitement. All right. So everything else that you have to do today is posted on Google Classroom. If you have any questions, please let me know. Send me an email, and I will see you next class.